When it comes to locally hosted AI, my interests tend to lie more around running LLMs or perhaps stable diffusion or even video generation and things of that sort. However, I really can't help but notice that there is a lot of interest in the actual vision capabilities of AI capable devices. Now, when I say vision capable, I don't mean running a multimodal LLM which can see a picture and answer questions about it, but I'm actually referring to the ability of little devices like these to actually take a video stream as input and be able to detect and classify specific objects from within that stream. Now, that essentially leads us into the whole point of today's video, which is going to be a sort of fusion of a few different things. One being a kind of tutorial, a kind of comparison test, and just a kind of benchmarking test between the vision capabilities of the Jetson Orin Nano Super and the Raspberry Pi 5 with AI Kit. To actually go ahead and run some of the software that will allow us to experiment with these image capabilities is not as simple as just downloading Ollama on one of these devices and then running inference on an LLM. You do need a few extra things, and that is really kind of why I have this little orange layout or spread, if you will, in front of me. So, of course, from right to left, we have the Orin Nano Super, which if you've been watching my channel, you're likely rather familiar with at this point, as am I. The Pi5 8GB. We have a camera cable, which will actually allow me to plug in a small little webcam to either of these devices. We have an opened but unused Raspberry Pi 5 AI kit. Now, it does seem that they came out with a more powerful one of these. However, mine is the up to 13 tops version. So just to make note of that, I have an opened but unused, extremely cheap 5 megapixel webcam from Micro Center or Inland, which is the Micro Center store brand. And finally, I have a Raspberry Pi 5 unopened, unused active cooler. Now, I do need to go ahead and actually install the AI kit and cooler onto the Pi 5. So I'll probably just time-lapse that, as I don't really want to spend a lot of time showing you me like screwing things into a circuit board. And then following that, we're essentially just going to start with either of these devices and go through the steps to install the necessary components and start to run and see how they do.
Welcome to the show.
We're going to begin with the Pi 5 because I put the camera on that, so I figure let's start with that. We're now going to go ahead and just follow the steps to get a basic pipeline running, which essentially, as it states here, will demonstrate object detection, human pose estimation, and instance segmentation. To begin, we're simply just going to not do that. Okay, to begin, we are going to just clone this repository. Once that is completed, we will navigate to the directory. And once in there, we will run this installation script. Once that has completed, we're just going to keep going down the line here, and we are going to configure the environment by just copy pasting the source setup env.sh. Now that that has been complete, we can go ahead and do the pip install-r requirements.txt, which will go ahead and install the required requirements in this environment. And it says the rapid.json.dev package is typically installed by default on Raspberry Pi OS. I have not seen any indication here that that package is missing. However, I am wondering if maybe I'll just try this anyway, because if it's already installed, it will just say the requirements already satisfied. Okay, so that's fine. Maybe perhaps just a good thing to check, I suppose. We are going to download the required resources by running this script. And basically from what I am seeing there, it looks like it errored, but it just seems to show that these required resources are already downloaded, so it's not going to retrieve them. So I would assume that this is actually okay. And following that, we are going to run the post-process compilation script. Well, that kind of sums up the initial, seems like, pre-steps to actually go ahead and start playing with some of these examples. So we are now just going to run this example. Now, considering we are in the same terminal session and have already done this, we don't need to do this again. And we are simply going to just go ahead and run the detection example. Now, I have not done this before. I do have the little webcam kind of plugged in and hanging off the table. So I would assume that hopefully what we see from here is, oh, okay, so my mistake, but this is actually really quite cool because it is working. So it is running it on the demo video, which is what we see here, but the bounding boxes along with the actual labels and percentages on each are actually being generated from the Raspberry Pi's AI accelerator. So this is actually really quite cool. And we can see that it is just kind of doing its thing. I don't know why, but like for some reason I want to like touch the AI accelerator to see if it's hot. I'm not going to do that, but this is actually kind of cool. So now obviously we want to do this with our own video. Now, if you are using the attached Raspberry Pi camera as I am, essentially we're just going to click the running with different input sources tab, and that will bring us down here. And there is actually a rather simple command that just adds on a flag of input RPI, which should essentially just be the default Raspberry Pi camera plugged into one of the camera ports. So what I'm seeing here does not look good. Are just going to try this again once more with the Raspberry Pi camera input, and we will find out if the error was on me or if it isn't. Yeah, okay, so all right, so here's a top tip for you folks. If you want to get this working and not look like a moron, the gold contacts on the camera cable need to be facing towards the Ethernet port, or all of, so the gold contacts here need to be facing towards the ports on the Pi and not away from the ports. I'll show a picture of what I mean. So, oh wow, this is actually working right now, even though it's upside down. All right, I probably will end up using this because this thing's awesome, and I bought it because I was enamored by its miniature yet mighty look. But basically, we're just going to go ahead and, oh wow, this camera's not that bad. Person. 90%. So hey, we're running right now AI object detection on the little Pi. Chair, not quite. All right, what are you looking at up there? Because that's a laptop. Oh, I got it. Look at that. Look at the sorry, I got excited. The iBook G3 is being identified. And on top of it, okay, so I'm sorry. This is probably terrible right now because I'm not really umbrella. I could see that. I accept that. This is really quite interesting. And this is honestly the first time I've actually played with any of this. Truth be told, I won't say that I didn't find it interesting, but I just couldn't really think of many use cases that would pertain to my own personal workflow with this, if you will. But this is actually really cool. So it thinks this red key's about. All right. Here's what I'm going to do. I'm going to go ahead and get the camera situation sorted so that I actually have a stable frame of reference for this. And then we'll just try having it detect some things. But this is really cool. So if you're running a script like this and you want to get out of it in the terminal like this, you just press Control and C, and that will gracefully end the process. Very cool. After learning that I have absolutely no idea what the correct use case for a telephoto lens is, we are now just going to revert to using the simple little camera that I had originally set this up with. Now, to get back into the examples, if you don't want to have to go back to the GitHub, in the terminal, you can actually use the arrow keys to cycle through previously entered commands. So essentially all we have to do is just go back into the directory. We need to source the virtual environment. And upon completion of that, we basically just run the Python script again with the flag for the Raspberry Pi's camera. Now, you can see I do have a few things in here. We have a mannequin over there, and it is actually detecting that as a person, which is pretty cool. So now, don't mind me because I have actually just taped the camera to the monitor. So if I kind of like use the monitor as tilt, so it's showing me with pretty high detection. Again, I'm not very versed in this, so I figure we'll just kind of put some things into the screen and kind of see what's going on. So like an automaton. Okay, it thinks this is a remote, but all right. Person. What about, let's try an Oculus headset. Apologies if this is very difficult to watch right now as well as here, because I have to kind of keep the mic with me, but let's remote. Okay, so, and again, you have to remember that this is only using the training of the models that, okay, sorry, what am I trying to say? The model is only trained to detect specific items, so it is likely, if you were to train it to actually understand what a Quest headset is or something like that, then it would absolutely be able to identify this as well. But it seems this is more for like testing a person or something like that. You can see that it does show the laptop behind me. Well, it did before. We saw that originally when I had first actually tested this. So this is interesting, and I suppose I'll try it with one more like interesting thing. So I'll be right back. I need to go and acquire a dog. All right, so I brought a dog. This is Betty. She doesn't like it up here, but it is getting dog with 90% accuracy. So really kind of cool. And yeah. Okay, good job. As a quick side note, I've been making a gaming computer, well, a micro gaming computer case for the Orin Nano. So I won't make a video on this, but I just wanted to show. So if people are interested in a case, I'll have this finished at some point. And it's totally not inspired by anything at all. We now have the Jetson Orin Nano Super setup. The camera is plugged in, and just like we did with the Raspberry Pi, we're essentially just going to follow along with the tutorial on how to get the object detection library and model running. Now, the Jetson is a bit more complicated for the initial setup and actually getting all of this to be able to work as simply as you will likely see it work right now. I did put out a rather in-depth tutorial that, if you are interested in doing this on the Jetson, would likely be a good place to start before you just try to jump in and kind of follow along with what we're doing here. Now, with that kind of disclaimer out of the way, I am basically just going to go ahead and run this command, which will essentially download the container that will allow all of this to run on the Jetson pretty simply. Fingers crossed, hopefully. And this will take a little bit of time, so we'll fast forward, and once this is done, we will hopefully be able to easily play with some object detection. Once the container has finished downloading, it will essentially drop you into the shell for that specific container. Now, I have just gone and exited out of that because there was a few other steps that I wanted to go over before actually trying this. Mainly just kind of running through this one myself first, as sometimes there can be a few more intricacies with getting some of these examples working as opposed to the one we looked at on the Pi. Now, being that I have done that, there are a couple of considerations I want to quickly mention, and that is here it just says for the live camera example, ensure you have a camera device connected. However, if we go into the Jetson Containers GitHub, the instructions are slightly different, and they specify you need a USB webcam device connected for this example. Now, I was trying this with the Raspberry Pi cameras and was not having any luck, so I eventually went to the GitHub because sometimes the instructions can have some different verbiage and things like that, which may be able to help you more on the GitHub. And I tried a USB webcam and it worked for a shot. So basically all we're going to do now is just go ahead and run this live example. And basically we'll get a bunch of terminal output and things like that, some things that may look somewhat concerning. However, ultimately we will be met with a URL which we can go to, and we will see the example running locally on our Jetson. Now we see our URL, and you can simply hit Control and then click on it, which will open it in your web browser. However, that would open it in Chromium for me, which I don't want to do. I want to stick within Firefox, so we're just going to do it here. And sorry, it's hard to like keep this all oriented, but we can see, so we see the actual image there, but we don't actually see any bounding boxes or object classifications, which can be a little confusing on first sight. So eventually, essentially for this, we actually want to specify what we have this looking for. So I'm just going to start with person, and we put brackets around that, and that actually will go ahead and then draw a bounding box around it with the classification when it does see a person. So I actually saw for a second, there's a Napoleon Dynamite. I understand now why like weather people have a difficult job because they can't see. The Napoleon Dynamite right there was quickly showing person for a second, and you can see right now when I point to it, that seems to somewhat help it. So we can basically just, I think we can stack these, but I don't know. So I'm going to try to. Oh, wow. All the laptops showed up when I hide. So this is very cool, as you can see. Definitely, this is a different sort of implementation than what we saw with this working on the Raspberry Pi, but it is kind of the same thing at the same time. So I'm going to basically just try, like, I'm going to try to, let's see. I don't know what this is trained on, so depending on how these models are trained, really allow me to rephrase that. With an LLM or something, it has knowledge based upon what it was trained on. So say an LLM was not trained to know what a VR headset was, then it would have no understanding of what that was. So this is essentially the same thing. So I want to type VR headset, but I understand it very likely will not know what a VR headset is because I don't know that this would have been in its. Okay, I'm not ready to give it credit yet because I want to do one more thing. I want to see if I can trick it to see if it was just kind of guessing there and it was a lucky guess. Okay, so if it says these are sunglasses, then I'm not impressed. Okay, even if I mean, I can't see when I. Okay, so that tricked it, but if I put them without my face, it doesn't. So this is quite interesting, really. And as this is one of my first real experiences with these sorts of technologies, I am impressed with this. And now that I actually am using it hands-on, I can kind of think of some more use cases and things like that for something of this sort. I do want to show you one final thing, and that is essentially that you can browse to this from other computers on your network. So I'm going to hop over to this one real quick, and basically we'll be able to see this same interface on a different computer, which could be of use for a lot of folks have talked about home automation and things like that. So basically you could have an edge device like this set up somewhere in your local network around your house or something like that. And then you could just kind of hop onto your computer and monitor it or have it send you alerts if it detects a specific object that you want alerts for or something of that sort. So it is rather cool, I guess, to say the least. Oops. And it's hard to see and hear, but we can see on that computer, which I'll put the screen recording up from this computer for a second, but you can see that it is the same sort of thing. So just kind of cool, and the local network capabilities of this are very interesting. And you can actually see here in the terminal output on the actual Jetson that it's saying, hey, 125 is accessing this on port 7860 on this machine, 125 being the IP address of that computer. So overall, this is really quite cool. And again, this is just a sort of brief, light touch on some of these things and not really an in-depth tutorial, as I want to get my feet wet with some of the image stuff as well. So we'll try, I suppose, one more thing. Let's see if it sees that bass over there. I'll just call it a guitar to make things simple. But yep, very well. That's very interesting. Let me try book, because I do have some books stacked up on my AC there. And okay, not quite. It seems like the chair is kind of getting in the way. Yeah, well, I could probably play with this for longer than you would want to watch me on camera just do this. So To wrap things up, this was just sort of meant to be a sort of comparison, but not necessarily a head-to-head performance comparison, but just kind of a comparison of the overall ecosystem and steps you would need to take to actually go about using some object detection on either of these little AI-powered or AI-enabled edge devices. There are some considerations when you're thinking of either of these, namely price. Now, this is a Pi5 8 gig with the AI hat, and this is the lower powered version of this AI accelerator. Overall, when you factor in micro SD card, power adapter, etc., this is going to run somewhere probably around $180 for everything you need to go to plug and play, not including the camera. And of course, the Jetson Orin Nano Super is $250. And then of course, you also need to just make sure that you have the micro SD card for this as well. And if you want to put an SSD in it, you can. But I haven't gotten to actually boot directly off the SSD on this yet. I know a lot of folks were interested in that. That is something maybe I'll look into in the future and do a tutorial on. But for now, I'm honestly okay with how the micro SD has been performing. And basically, this was just kind of a cool test. And this was one of my first real hands-on in-depth experiences in actually using the image and object detection classification capabilities of AI edge devices. And I have to say, this was actually kind of fun. And I am going to ask those of you watching to do me a favor, and I'm not going to say subscribe. I don't do that. If you can think of a good use case for this Raspberry Pi telephoto lens, preferably in conjunction with the example we saw running on the Pi with the AI kit, I really would like to actually just have this running somewhere like 24/7 along with this and seeing what it can do. Because this really was interesting to me, and I unfortunately could not get it working well enough to show. The image that I got out of the telephoto lens was just super blurry, and I attribute that to my lack of camera etiquette or knowledge. So that's essentially going to wrap this video up. I hope it was useful and helpful, and Happy New Year. Thanks for watching.